It's time to continue the higher education track. We are left with 2 sessions and we have decided to merge both sessions due to scarcity of time. So the first session is utilizing technology to attract and retain students to increase and improve student diversity and to ensure efficient student life cycle management. And next session, effective management of transnational education, reaching financial stability while providing high quality qualifications and an excellent student experience. We have a wide range of speakers and panelists in this session. To begin with, I would start with industry presentation, and later on we'll have a panel discussion of all the eminent panelists. So I request Dr. S. Nabi, Director, Learnengg, to please come on stage and give your presentation. Welcome him with a huge round of applause. Dr. Nabi.
Good evening. I am from InfoPlus Technology, Chennai. We are here to talk about the technical education, how the technology is impacting, what are different things are coming up. First of all, let me thank the organizer to giving us this opportunity to present this presentation. So whatever I am talking here is for the technical education starting from graduate engineering, polytechnic, ITI, and the skill development courses. Let's look at it, the difference, what it has happened last 25-30 years in the academics of technical education. We had a BE 5 years course. Most of the syllabus are not well defined, or it is mostly solution oriented. We never bother about objective type questions before 90s. After the self-financing engineering college opened up, it became mostly 4 years course. Scoring mark became important, and the examination pattern continuously changing towards the objective type questions rather than getting into large answerable big size answer questions. That's what it has been there. Because definitely I can, with confidence I can tell, because graduated in 1986, started the whole career on CAD/CAM and digital education. So has the depth of the knowledge, what it has happened in the academics and in the technology. Let's take on the industry side, what it has happened on this 30 years. In 90s, when you get selected for a Tata or any other large companies, the industry used to give 1 year graduate training program. It has gone totally now. Whatever the industry now say, give me industry ready students. We do not know where the industry readiness can be made, inside a classroom or inside an industry. That's a big question mark. Any debate can happen towards that. And another thing is, before 90s, you had a lot of the students, engineering college students or a polytechnic students had opportunities, or it is important for the student to do an industrial visits, which has been slotted in the academic calendar itself, has gone. It does not exist anymore. If maybe as an interested candidate or they are doing it. But other thing is, whatever the skill building of individual, as of now, whatever the IT industry asks or core engineering asks, every industry looking for industry-ready students. How do the academic going to address this biggest challenge now? And the technology, definitely we are having the best technology for learning and the teaching now currently across from the school to the colleges, it is available. Then what it comes, the technology given me online education or e-learning. So most of the time for the more than 10-15 years, the e-learning means it may be a PDF file or an e-book or a text in a remote, communicated from a remote location or through a server. Or what the next term it comes, including the government, has done a lot of investments on the preparing this e-learning, which all monotonously lectured by a professor from the state capital to all the engineering college in the state. That's called the EduSat educational system, which has come. But what it has happened is that a student, the previous sessions also, that was the discussion which was going. A continuous video, whether a professor is talking or a continuous video something is running, we have done a research for 2 years, find out what is the best for the technical education. I can tell you, in my technical classroom, if I run any video more than 5 minutes, I lost my 50% of class. I cannot attract any more. So that became a boredom. So what next my technology can ask for? That's what we are trying to evolve ourselves. Then as I said in the 2 minutes before, industry readiness, from where it can come. So now it is compulsion for academics to prepare the student with the skill. But what all the state governments or the policy making bodies across the country have looking at the skill development as a separate compartment. This is like you do a formal education in BE or a polytechnic or ITI, then join another course for skill development. The skill for a technical skill cannot come as a separate compartment where I can define first day to last day. Skill will not come through that. Until you acquire the skill need to be built over the skill knowledge, the skill development need to happen. So that's where the qualitative difference need to make. So what we have worked on the last 7 years, particularly how do we build application, the product which can go to the classroom or a self-learning by combining the industry learning as well as on the typical classroom learning. That's what we have came out with the 2010 visual rich e-content for technical education. That's where we have been working for last 7 years. We have only developed the content. Now we are into the market, started doing our implementation. Let me get back to you what we offer. We offer the one-stop e-content for the technical education for all branches and all courses. It's a high-quality digital content, definitely, exploiting the technology on a visual side, and basically we use a lot of 3D models, what industries are using it. And then we also using the all personalized devices for that. The one more thing which I want to emphasize here is, there are across the globe only 2 ways of learning in a technical classroom or a technical learning. One is you learn the things through a fundamental concept. Another one is you learn things through application concept. Most of our Indian educational system advocate the fundamental learning system, that is, you learn principle derivations, so solve the solution, at the last one line will be applications. If you go to a Western classroom, developed countries, where I am taught through applications. They will, for example, if I need to learn a DC motor, a professor will bring a prototype of DC motor, start doing, this is the DC motor we are going to study about, and he start doing the design details and go. At the end, he may leave the class, this uses the Faraday's law, tomorrow the assignments are on Faraday's law, these are the assignments. This is how we dictate. But in our class, we do 50 minutes, the complete Faraday's law derivations, then while going out, we will say this uses DC, this principle have been used in DC motor, and they leave. So most of our classes concentrate on the fundamental derivations problems, whereas the Western classes concentrate most on the applications. So what the solution we have evolved, combining the best of these two, came out this solution. That's what we are presenting it to you today. What's the other thing, the problem of the technology being importing the academics is, for my student at the current rate, I cannot give anything extra. Anything extra, it's not accepted by the students. So what I can do is that we develop the content as per university syllabus. So that's the most important part, is that last 7 years, 250 people have been working for 7 years, has developed complete visual for the different engineering branches. For example, you take a typical university subject, which is a 50 hour or a 45 hours, depending on the lesson planning university announces. That 50-hour lessons, we are converting to a 300 3D, 2D demonstration in a visual form. That means in a 1 hour class, I may take 4 minutes to explain that text, oral communicated content, or a blackboard writing to a visual form, 3 to 4 minutes video, which will come in 1 minute in slot. So whatever the product we need to deliver to the Punjab Technical University or Anna University down south, we customize the content what we have built last 7 years as per their university. And one thing I can definitely tell you is that we have not done copy of any internet material or taken some e-book copy. What we have done is built a remote contribution from most of our retired professors who are supposed to be the experts who has taught the very conventional form of engineering teaching in this. That's why a professor in the classroom definitely will say in 90s, imagine that it works like that. That has gone. That cannot be handled anymore. Now we can visually see these things. So what we have currently is that we have exclusively development completed for 225 engineering subjects across 10 branches of engineering, which can be applied to the different levels. And to explain these 225 engineering subjects, we have done 75,000 visuals developed. Each visuals are 1 minute and around. And we have done the more than 1 lakh people across the country currently using it. And we have been doing some of the government implementation, which I will come back in the next slide. Then next, whatever we are, the NSQ framework, we have mapped up whatever the content we are doing it according to the requirement what NSDF. The principle of this complete product is 3D way to learn. So we will complete whether it is understanding the fundamental law, working principle, derivation, these complete things we have provided. So we deliver through all the models, whatever the cloud model, you can get it in your Android tab. All those things are well known, I am not repeating it. Currently we have done 77 government ITIs of Kerala. We have done the implementation Andhra, Telangana, West Bengal on the polytechnic, government polytechnics. We are currently working with Visvesvaraya Technological University and the Pondicherry. And through our online portal, we are delivering to Anna University and 8 universities what we have listed. More than 75,000 users, and it is more than 100,000 hours have been used. That's what we have achieved so far. We are also recognized by Government of Kerala for the best rural KEL student skill development for the 2 years implementation. I will make small implementation. By that, I will complete my presentation here. So this is the product what we have developed. So this can be customized. Just I am making a demo of it. Here it is. This will be the content as per whatever the content university syllabus is giving it. It can be, if the regulations are changed, we can change the regulations. And here what we do is that we give the complete demonstration. This is what the demonstration what we mean. So for example, a construction of a DC motor, we give so this will give the complete development in a 3D platform. This is all developed in the MCAD system and used the entertainment media to make these animations and other things. And these are built completely as per the requirement. What I mean the requirement is, in a class I am talking about construction detail, we give construction detail. Then it is getting into testing method, then the demonstration on the testing will come. So this will give you the complete demonstration. For example, what I said is that if you take the lesson planning of a DC motor, it will be 7-hour course. For that we have 36 demonstration in a 3D framework we have developed for this. So this will completely cover the lesson planning what it has been given on that. On the second part of it, what we have done is we have used 3D model explanation for the solving the problems also. For example, you take typically in a tutorial class, professor will come and give the tutorial problem, then use the formula, get the answer. This is what typically happens. But what is the industry expectation or the skill knowledge related to is, whatever the formula, whether I say voltage or the armature current, the armature current, it means where do I measure the armature current is a skill. Armature calculation is the skill. The parameterization of a motor comes from the tutorial problem. That's the impact we are not making it. So even the tutorial problem we have completely managed with this, explaining the each content or the parameter of the problems through the, for example, you can see here, this is the motor.
The supply voltage is 220 volts.
So this we will exactly use the 3D model, explain how it has been done. So this is how we have, each and every problem we have gone depth of this.
Armature current is 50 amps.
So armature current is measured, number of winding is this much. If it changes, what the current will
Armature
change or the design will change is the
RA
parameterization.
is 0.2 ohms.
So this is all will run for 1 minute or 1.5
Find the
minutes.
speed, N.
The another typical technology, this one is that everyone is commenting is that who are you to give me the content, whether it is the full, not good enough for the student to study that. That what we have done is, we have, for when we are writing the content by experienced professor, we also taken a pain to get into the internet, whatever the different available content in the net for that specific topic, we have collected all those specific website location and given here. So that's the one thing, because what we say, the content, the examination point of view, understanding point of view, but if my student want to go beyond that, all that collection of material we have given. So this will give a complete end-to-end details what a student is requiring. So this will give you the better for the, in terms of not taking the classroom totally on a mark scoring basis. Let understand the engineering through visuals and let do the skill development within the course, not as the separate compartment. Thank you very much. Thank you for the time.